Hello everybody. In the last section we did talk about displacement, position, as well as the meaning of time interval. We said that the displacement of an object is simply the change in the position of that object in a given direction. So displacement is a vector quantity measured in meters. Keep that in mind. Time interval is the change in the time as an object moves. Understand that time is a scalar quantity measured in seconds, while displacement is a vector quantity measured in meters. In this lesson, we will talk about speed and velocity. Speed and velocity. The speed of an object is how fast that object is moving. The velocity of an object is how fast that object is moving in a given direction. So look at the difference. Speed, how fast an object is moving irrespective of its direction, while velocity is how fast that object moves in a particular direction. That means that speed is a scalar quantity and velocity is a vector quantity. Now we will begin this session by looking at the average velocity and the average speed. So suppose we have John standing on the road. This is Johnny, and he is at an initial position xi, and he is walking to the right. Let's say he walks to a final position xf. So the question is, what is his displacement? This is his displacement represented by delta x. I'm going to put here a bar because it's a vector. Now delta x bar is simply equal to xf bar minus xi bar. This is his displacement. We are essentially assuming that this is our origin, and this is the x-axis to the right. So the question I want to ask you is, what is his average velocity? Now, the average velocity of John or any object is simply described or defined as the displacement of that object in a given direction divided by the total time taken, or the total time interval. We know that initially John is at a time ti, and when he comes to a stop, his final time is tf. So the time interval delta t is equal to tf minus ti. So John's average speed, v average, I'm going to put a bar on it because it's a vector, is defined as the displacement of Johnny divided by the total time taken So this essentially implies that the average speed is equal to delta x divided by delta t. This is the definition of his average speed. If you notice, you will see that displacement is measured in meters, and time interval is measured in seconds. This would mean that the SI unit of V is meters per second. Is meters per second. So keep in mind that average velocity is defined as the displacement of an object divided by the total time taken, and it is measured in meters per second. Now, it is a vector quantity, meaning that it has a direction and a magnitude. So the question I want to ask is, what then is, how do we determine the direction of his direction? Delta t is always greater than 0. And by the way, it is a scalar. This means that the direction of the average velocity is the direction of displacement. Let me say that again. The direction of average velocity is the direction of the average the direction of the average velocity is the direction of displacement. It's important you keep that in mind. In other words, V bar average has the same direction as delta X bar. Now, here's the deal. It means that if delta X is positive, V will also be positive. Also, if delta X is negative, V will also be negative. So the question is, when is delta X positive and when is delta X negative? Now, this is a very simple question if you look at the number line or the coordinate system. So if delta X is greater than 0, it simply means that XF is greater than XI. This is only true if the object is moving to the right. On the other hand, if delta X is less than 0, this will mean that XF is less than XI. This is only true if the object is moving to the left. So what can we conclude? We can conclude that a positive velocity means that the object is moving to the right, and a negative velocity means that the object is moving to the left. Let me say that again. A positive velocity implies the object is moving to the right, and a negative velocity implies that the object is moving to the left. So the sign of velocity determines the direction of motion of the object. So what does this all mean? This is our origin. If an object, let's say John, is located on this side of the origin, X is greater than 0. If he's located on this other side, here X is less than 0. But if John is moving to the right, V is greater than 0, but if he is moving to the left, V is less than 0. So what does this all mean? So we can conclude that 1, If x is greater than 0, it means that the object is to the right of the origin. It means that the object implies that the moving object is to the right of the origin. If x is less than 0, implies that the object is to the left of the origin. Now, 2, if v is greater than 0, that is a positive velocity, implies that the object is moving to the right. And if v is less than 0, implies that the object is moving to the left. Now, here's the deal. If x is greater than 0 and v is greater than 0, what does this mean? This is the scenario where x is greater than 0 and v is greater than 0. In this particular case, the object is moving away from the origin to the right. If x is greater than 0 and v is less than 0, what would that imply? This would mean that the object moves towards the origin from the right, that the object is moving towards the origin from the right in this particular case. So we will have, this will be v less than 0 and x greater than 0. Another scenario will be v less than 0 and x less than 0. What do you notice? You notice that the object is moving away from the origin to the left. So if x is less than 0 and v less than 0, the object is moving away from the origin to the left. Now, if x is less than 0 and v is greater than 0, in which case we have something like this. This is v greater than 0. What do you notice? That the object is moving towards the origin from the left. This is important. So the object is moving towards the origin from the left. What do you notice? There are 4 different scenarios here. You notice that when x and v are of the same sign, the object is moving away from the origin. But when x and v are of opposite sign, the object is moving towards the origin. So let me say that again. When the position and velocity carries the same sign, the object is moving away from the origin. But when the position and velocity are of opposite sign, the object is moving towards the origin. It's important. We are going to use this in the future in analyzing the motion of objects. Thank you very much. If you have any questions, please do not hesitate to ask in the discussion forum for this course. Bye.